So hi guys, so today we would be starting with hands-on ML, yet another uh, thing that ML topic. So today, last time we learned about instance versus model-based learning. So we learned about how all the two types of model-based and instance-based learning work, and what are the features and how all the things work. So today we would be learning an example of model-based learning. I wanted this to be a dedicated video regarding model-based learning. So before we start that, let's discuss about all the things that we studied about it. So model-based learning is yet another way of generalizing form of set of examples to build a model of these examples, then use that model to make predictions. This is called model-based learning. Here you can see uh, I'm using an example, that is import the libraries, load the data, prepare the set data, visualize the data, select a linear model, train the model, make a prediction. So this is the place where we are going to execute our code. If you don't know about this is a Google Collaboratory. I would recommend you to watch my first TensorFlow video in which I talked about what is Google Collaboratory. You can imagine this just as an online Jupyter notebook. If you are familiar with Jupyter Notebook, you are good to go on Google Collaboratory. So here you can see where we are going to take the two data sets. So the first thing we are going to do is import the libraries that we are going to need in our model. So the first library we are importing is mat.lib.pipe.splt, then numpy, then pandas, and then sklearn.linear model. So you must be thinking why I have imported a linear model. So basically we are going to implement a linear model here. In future we are going to test different models also. So once you are done with the importing libraries, what you need to do, you need to load the data. So here I am loading the data. So this is pd.read.csv. What it is doing, it is reading the data that I am giving to it, and similarly this is also being done here. And if you want to know more about the data, these are the two data sets I'm taking. The first is GDP per capita, in which almost all countries are here, and all the data set of all the countries, I guess not all, around 190 countries are here, and the GDP per capita of each country the year 2015 has been mentioned here. And after that, this is a OECD Bleed 2015, in which the happiness of the person, means the life satisfaction of a person in a particular country, has been noted down. So we are going to see that how these both things are connected to each other. You must be knowing that the more the GDP per capita is of a country, the more happy the people of that country must be, because economically their country is doing good. So we are going to run this. We're going to load the data, and you don't need to worry about this part. This is just basically preparing the data. You need to look at this part, that this we are going to prepare the data. So what is preparing the data? Suppose this data has something missing values. Now suppose if you can see here in this there are missing values, so we are not going to take this value, we are going to remove this, in which these there are not available values. So yeah, just like this we are going to remove the data, and we are going to remove the data which is going to cause trouble to a model and is not complete. So what we are doing, we are putting this prepare country stats function here in our data. We are just looking that if the data is good or not, because you know I always focus on how good the data is, because the better the data, the better the model would perform. You don't need to worry if you don't understand this function, and I don't expect you to. You just need to focus on this, that we are going to do country stats equals to prepare country stats, and we are going to pass this function here. And after that we are going to perform this action on x and y, where we have already defined that x is equals to GDP per capita data, y is equals to life satisfaction. Now we are going to let's plot a graph. Let's plot a graph between both the relations. So what I would do, country stats here, if you see here, prepare the data and visualize the data. So this is the part where we are going to visualize the data. I would just run this code. Here what I have done, x equals to GDP per capita, x is here. and y is life satisfaction. If you want, you can reverse that order also, but it is not going to make any difference. And that kind is equals to scatter. You can use any type of kind. You can, I would prefer, I recommend you to go and explore this libraries and stuff. So you can see it is really common that the better the GDP would be, the happier the life satisfaction, the more life satisfaction would be. Means, what can you expect from a country which is performing really good in its economic growth? Definitely the country's life satisfaction of people would be really high. So you can see at 50,000 it's 7.5, at 20,000 it's slightly 5.7 around. So yeah, now what we would do, we would give our model and tell it, okay model, please work on this data and teach yourself, we would basically teach the model that if what the stats are basically saying. So what I would do, model equals to sklearn dot linear model, linear regression, and I would run it, and then I would simply do model dot fit. Here we have defined the model, that what our model is basically going to do. Our model is going to be a linear regression model from sklearn, from where we have imported. And now once we have defined the model, we are going to put our data set in that. What we have done, select a linear model. We have done things till here. Imported libraries, loaded the data, prepared the data, visualized the data, and we have now selected the model. The next thing we are going to do is train the model. And what thing we are going to train up the model on? It's obvious, the data we have. So what was the data? X and Y we defined here. X is equals to GDP per capita and Y is equals to life satisfaction. We are going to simply run that, and model dot fit has been done. Now what would happen, we would make a prediction. So let this prediction be 22,587. Now I want you to pause the video and just look at this graph and imagine what according to you is going to be 22,500. So according to me it's going to be near something, according to me it's going to be near 5.8 or 5.6, around 5.6 I guess. Now we would run this, and yeah, it's doing 5.96. So yeah, it's I told you about 5.8, it is 5.9. So yeah, it's doing pretty good. It's 95% accurate, close I guess. If you do something else, suppose if I do of 22,000 exact, or let's do it of 23,000, then what it would do, it would give us 5.98 this time. Now let's do it of 35,000. Now I guess the value would increase. Yeah, it's telling us 6.57. So on 30,000 what it is going through. So yeah, 6.1 we can expect. Yeah, 6.1. And let's do of 50,000 the final number, and I guess it is going to show a really high number, 7.3. So 50,000, yeah, it's actually showing exact 7.3 here. So models accuracy can vary from the type you are going to train a model on. So we have followed all the steps, we have trained the model and made a prediction. So these were the steps. I would just brief you again. Imported the libraries, we loaded the data, we prepared the data. No need to worry if you don't understand this. And we visualize the data, that how the data is looking, the correlations we are going to say, and select a linear model, and we are going to train that model on the data we have, and then we are going to simply make a prediction that how our data is performing. So this was a really simple example, the simplest example available. In future videos we would talk about some complex examples also. I would recommend you to go to see my TensorFlow videos on computer vision and NLP. We talked about some complex examples there, huge data sets working on. So this was it for the video. I hope you got the idea what is basically model-based learning and how it is working, all the steps that have been followed. So thank you and have a nice day.